Hi everyone, in this video we're going to just briefly introduce power series. So we now know how to test many infinite series of numbers for convergence. We've gone through quite a bit of convergence tests for different types of series up until this point. Now a function that is difficult to compute can sometimes be replaced with what looks like an infinite polynomial. So when we first talked about sequences and series, we kind of briefly touched on this, but now that we've learned a lot about series, we're getting back to this fact that if you're dealing with a function that's hard to work with, you can, some of the time, replace it with what looks like an infinite polynomial, and how that relates to series is the infinite polynomial is a series, and is specifically a series of powers of x. So we will define this properly for you in just a moment. Now, power series, like polynomials, have similar characteristics and operations that can be done on them. So you can add, subtract, multiply, you can even differentiate and integrate power series, and then the result is another power series. So using power series, we can actually extend ideas and methods from calculus to a large variety of functions. So now let's get into what a power series looks like. Now, a power series about x equals 0 is a series that has this form. Notice our series notation, we're adding the terms, our summation, starting at n equals 0 going to infinity, of c sub n. C is just a coefficient times x to the n. So the power part is the power on x, so x to some power. And then when n is 0, it's just c sub 0 times x to the 0, which is 1. That's why you don't even see the x in this first term. And then x to the first power, x to the second power, and so on forever. So that is our power series about x equals 0. Our power series about a different value, x equals a, in general, has very much the same format, but notice what you have with x. You now have x minus a. So this a value is actually like the center. We call that the center. And so you have x to some power, but you have to say x minus a quantity to that power. And so if you think about polynomials, if you see as we start to expand this series on this second power of n, so when n is 2, you would FOIL this out. It would just be a binomial times a binomial. On the third term, you would just FOIL twice. You would have a binomial 3 times, and so on. Okay. So this power series we call a the center. Notice also a is after the minus sign. So for example, really quick, just to distinguish, if this had a plus sign, if this said like x plus a, then the center would actually be the negative number. Okay, it would be negative a. Because basically the number here that's considered the center is the number that makes this quantity in the parentheses 0. Okay, so in this case, positive a minus a would make this quantity 0. That's why the center's a. And then the coefficients are just our c values. And these are all constants. Let's look at an example. So here's just a very nice example. The coefficients are all 1 here. So it's just 1 times x to the 0 plus 1 times x plus 1 times x squared, and so on and so on. So to write this with our series notation, we would have the summation from n equals 0 to infinity of x to the n power. So that's our power series. And then what does this look like? Okay, what does this equal other than this infinite polynomial on the left? Well, this is actually a geometric series. So if you remember what the geometric series converges to, anytime this base is between -1 and 1. Let's see if you remember before I show you. It was 1 over 1 minus x. Now, back when we were learning about geometric series, this numerator was a, and the denominator was 1 minus r. Okay, and so just to clarify, this is true anytime x is between -1 and 1. That's what this is saying right here. Okay, so what does this really mean for us? Well, on the left, these are all polynomials, depending on which n we go up to. So if we stop at n is 2, that's a quadratic polynomial. When n is 3, it would be cubic, and so on. So the left side here is all polynomials. We just call it P sub n of x. And then these polynomials approximately equal this function for this example. So we use these polynomials to approximate the function. So now take a look at these graphs. I have in this image the graph of the exact value 1 over 1 minus x, and then 4 other approximations for different n values. So the actual graph of the function 1 over 1 minus x is this blue one. And then the approximations of this graph are this polynomial on the left side, our equal sign, up to some n values. So notice we kind of get closer to the actual function, the blue one, as n gets bigger. So when n is, look at this one here, y sub 0. When n is 0, it's just a straight line. Looks pretty much nothing like our blue curve. When n is 1, it's getting up a little higher. It's the green one, okay? When n is 2, a little bit better, the yellow one. But when n is 8, when we take 8 terms to make this polynomial, look how close that red graph is. This red function is very closely approximating our actual blue function. Okay, so that is our brief introduction to power series.